All right, so collecting data. In God we trust, the rest of them bring data. We trust God. We don't ask data from God, okay, all of those who believe in God. But the rest of them bring data. It should be data-based decision making, okay? So we will introduce to data collection later in this chapter and cover in depth using units of sampling also. Okay, everybody has typed crystal clear in the chat box, okay? Thank you very much, everyone. This is just a quick check so that all of you see my screen properly. Okay, so collecting the data for improvement, process improvement. So we have established some metrics in the defined phase. Okay. And we ensure a strong understanding of the current process performance. It is very important to find out your current state in terms of your capability before establishing the future state and crafting an improvement plan. How many of you agree with me? For example, if you go to the doctor and tell him that you're not feeling well and you're having some stomach pain, vomiting, etc., etc. First, he will try to establish your current state. He will check your temperature, check what your temperature is. Oh, it is, in Indian terms, they say 103 degrees and or 101. And then he will also check your pressure and say, oh, this is your pressure. Maybe he'll check a rapid check of your sugar levels also. So first collect data of the current level, and then the future level. What should be your body temperature be? What should be the sugar level be? What should be the blood pressure to be? And then see the gap and try to give your treatment so that you can go from the current level to the desired level. If this is clear, type SC, super clear in the chat box. Okay. So ensure a strong understanding of the current process performance before leaving the measure phase. Sigma level or some process specific metrics like process capability, etc. CP, CPK will deal with that later. Use historical data to compare future results and validate improvements. Like I said, use the past data, current data, and establish the future data and validate the improvements. In case you don't have the data, for example, sometimes doctor also asks you for the medical history, right? It's similar to that. So how do you collect data? What are sampling methods? We will cover in a separate session. Okay. Now, okay, what do you see on the screen now? Qualitative. Okay, all of you type QUAL. Okay. Qualitative data is descriptive. It uses senses. Qualitative data is feeling. It's hearing, subjective. Okay. For example, if I ask you, for the people who have attended my training multiple times, or I'm asking the people who are in the training, how do you feel my training so far? Please put it in the chat box. If I ask you, what is that you will put? Let me see in the chat box. How do you feel about my training so far? Some will say excellent, fantastic, awesome, wonderful, good, great, very valuable, highly valuable. Okay, this is called as qualitative data. If you want to convert that into numerical data, I might ask you on a scale of 1 to 10, please give me a 9 or 10 if my training is excellent, awesome, so on, so forth, right? So I have converted this qualitative data into a numeric data. Okay, great. All right, thank you, Pero, for 11 on 10. Okay, so qualitative data uses the senses, feel, hear. Qualitative data is subjective. Okay, it uses all the 5 senses, see, smell, taste, and all that. On the other hand, so qualitative data is mostly like a feeling, right? Whereas quantitative data is through proper numbers. It's numerical, discrete, counting, continuous, measurement, factual, etc., etc. Okay. So if this is clear on a scale of 1 to 10, please give me a 9 or 10 if it is super, super clear. These are the two types of data, because in data types, we are going to go into the depth of qualitative data and quantitative data, which is very, very useful for further analysis. Very, very important. Now, overview of data. Data has got numeric and attribute. Okay, data has got numeric and attribute type of data. So what is numeric data? Anything in the form of numbers you can measure or count. You can apply a number to it. That is a numeric data. Attribute means observe and place into some sort of category. That is why it is sometimes called as categorical data. Okay, all of you type CD in the chat box. AD is also called CD. AD is equal to CD. Attribute data is a categorical data. AD is equal to CD. Fantastic. Now let me go into a little bit of depth of this. Please pay good attention to this. I will share these presentations sometime. Please don't worry about that. But please focus, because my time has to be a time well spent only if you learn and become valuable on this subject. Okay. Now, if you see here, I spent hours and hours in curating these presentations to make sure that it's so simple for you. Okay. So measure or count, there are two things, continuous and discrete. Let me tell you. So if I ask you, let me first go into how many people were there in your class during your first year of college? How many people were there in your classroom? Just put a number. Okay, 40, 40, 20, 36, 60, fantastic. Okay. Okay, now if you see here, this is called as a count data, okay, a numerical data, but then it is discrete. Suppose in this room, there are 3 people. If one person comes inside this room, how many people are there? Such a stupid question, right? Simple question. If there are 3 people in this room already, one person enters the room, there are 4 people. Is there a possibility of 3.5? Is there a possibility of 3.5? No. So this is called as discrete. Okay. Numerical data, count data, but discrete data. Okay. If this is clear, type clear in the chat box. Okay. I'll give the same example of this room where the air conditioned temperature is 27 degrees. Let's say the current temperature may be 25 degrees. Okay. Suppose if I change the temperature to 26, okay, can there be 25.5 degrees also? Yes, it can be 25.5. Can it be 25.51? Can it be 25.51? Yes, it can be. Can it be 25.51120? It is just that we are not able to measure, but the data is continuous. All of you type yes in the chat box. It is possible if you have a very accurate measurement device. But data is possible. But it is not possible to have 3.5 people in this room, but it is possible to have, okay, suppose if your weight, let me say that my weight is 65 degrees. Can it be 65.1? Yes. Can it be 65.12? Can it be 65.126? Yes. This is called as continuous data. And these are the examples I have said: temperature, weight, pressure, whatever. Continuous data means between any two data, there can be infinite data. If this is clear, please give me a 9 or 10 in the chat box. Discrete data means between any two data, okay, there cannot be multiple data. It can either be 4, 5, 6. No, it cannot be continuous, okay? Between 4 and 6, there can be 5, but it cannot have infinite number of data points between any two numbers. That's called discrete. This is very, very important, okay? Good. If so far, if it is interesting, useful, valuable, fantastic, awesome, put it in the chat box. Let me also draw some inspiration and proceed with this awesome session today. All right, thank you. So continuous data, it may be divided into ever smaller measurements, length, pressure, weight, and all that. Discrete data counts supplied at fixed levels like defects, number of times a specific response to the survey questions, etc., etc. Okay. And if you see the attribute data, okay, binary, ordinal, and nominal. Okay, binary, ordinal, and nominal. All of you know binary, right? Binary is yes or no, true or false, go or no go, pass or fail, and all that. All of you know binary. Ordinal means data is in order. Okay. Ordinal means data in order, like small, medium, large. Small pizza. What size of pizza do you want? All of you put it in the chat box. What size of pizza do you want? Small, medium, large. Okay, all of you want large. This is called ordinal data. Okay. Okay. If you're having some drinks, okay, whether you want small, medium, or large, what type of drink do you want to have in a party today? Okay. This is called as ordinal data. If ordinal data is clear, type super clear in the chat box. If ordinal data is clear, type super clear in the chat box. Fine. Now let me give you an example of the nominal data. How many of you like ice creams? Type like in the chat box. How many of you like ice creams? Okay, there are a lot of people who like ice creams today. Okay. Now my question to you, ice cream lovers, is what flavor of ice cream do you like? Strawberry, vanilla, pista. Okay, now, is there any order in these flavors? Can you put these flavors in any order? No. You cannot put it in any order, right? And this is called as nominal data. Like this is unordered. Which color do you like? Put it in the chat box. Red, black, blue. There is no order to this color. See, we might choose to arrange in alphabetical order this way, but there is no logical order to these colors, right? So if this is clear, give me a 9 or 10 if it is super clear. So far, if you found it interesting, valuable, useful, fantastic, awesome, put it in the chat box. This is a very important, interesting subject. I wanted to make it as interesting as possible. Okay. All right. Now, to obtain the same level of understanding regarding a process, let's say there is a balance like this. This is large amount of data. Okay. And on the right side, you see there's a small amount of data, but both of them are balanced. Why? Because even though it is small amount of data, it is rich with information. But even though if it is large amount of data, it doesn't give much information. But to get the same information, we need more data. Okay. Whereas here, to get the same information, you need only less data. And that is what is the difference between discrete and continuous data. Always try to look for continuous data. Now that you know what is continuous data, like numerical data and continuous data. Okay, always look for continuous data and very less discrete data. Okay, so IPL means it is improvement project leaders. Okay, sometimes convert the perfectly useful continuous data into discrete. Okay, so do not convert this continuous data into discrete data. Always keep it as a continuous data. Try to get as much of continuous data as possible, because the little data might provide a lot of valuable information if it is continuous. Okay. If you have understood this slide, okay, just type US in the chat box if you have understood the slide. This slide is, and if it is a new learning for you, if it is a real bulb on moment for you, type BON in the chat box. Bulb on moment for you, new learning, type NL in the chat box. Okay. This is really, really important that you look for continuous data. Okay, right. Thank you very much. Okay, IPL means improvement project leaders. Okay, improvement project leaders. Okay, now we have seen this. A numerical attribute. Okay, attribute data can also be sometimes converted into continuous data. I'll give you an example. Okay, I'll give you an example. Just answer my question exactly. Suppose if I give you an option, okay, how is Dr. Murali's training? Okay, and I give you 4 options: poor, average, good, excellent. Choose the best option. Poor, average, good, excellent. Okay, so this is called as attribute data, which is ordinal data. Ordinal data, which comes under attribute data. Okay, now this is the first one. Okay, thank you for reading that. The second thing is, if I want to convert that into discrete data, if I want to convert that into discrete data, I can always, if I want to convert that into numerical data, let us convert into discrete data first and numerical data. Okay, on a scale of 1 to 10, please give me a 9 or 10 if my training is excellent. Now this is a discrete data because I'm giving you only 8, 9, 10 and stuff like that. Suppose if I want to convert into continuous data, I can sum up all these numbers and divide it by the number of people. It will become a continuous data. For example, if 3 people give 8, 9 and 10, so 8 plus 9 plus 10 divided by 3, okay, or 7 plus 9 plus 10 divided by 3, it will become a decimal place, okay, and it will become a continuous data. Okay, if this is clear, type SC, super clear in the chat box. Very, very important to understand this. So if you have attribute data, a single part, good or bad, there are no numbers to analyze. But if we count the number of good parts and bad parts, now we have a discrete numeric data. Then we can analyze 2 proportion test, scatter plot, Pareto, which we are going to talk later. If you further take the count of good and bad parts per shift, turn it into percentage defectives, it is continuous numerical data. Whatever I've given here, some people may not be able to understand, and that's why I gave a very simple example of my own training scores, making the attribute data into discrete data into count data, okay, count into continuous data and all that, okay? All right, can I move on? Type MO in the chat box. I'll move on to the next slide. Okay. Good. Thank you. So continuous versus discrete data we've already seen. Now we will go a little faster. Okay. So it is important to understand the data type before graphical representation, because there is something called as graphical representation of the data. Descriptive statistics and inferential statistics is something that we'll take up later. But then if you just represent the data in numbers, it will give some information. But if you represent them visually through some graphs, it will give you more information. Okay, so there are various graphs that we are going to talk about later. We said continuous data, we have understood this time weight example. Discrete data, we have understood this also. So data is collected from a population sample or a process sample. What is population sample? Something which is already produced, and then you collect the data from that, or you have a running process and from there you collect the sample. So the type, collection method determine the graphical display and analysis. So later on we are going to see how this data collected can be represented graphically. Okay. Okay, discrete and attribute data we have seen very, very clearly. I wanted to drive down, nail down to make sure that when you go from here, it's very clear. Discrete data consist of distinct separate values, it is often arises from counting. We've already spoken about that. Number of shoes in the store. Okay, it cannot be 2.5 pairs of shoes. Okay, number of employees in the department, number of defects in the batch. Okay, it's characteristic, it's countable and finite, and data points are always whole numbers. There are no gap between the values. We've already seen this. Okay, either 3 defects or 4 defects, not 3.5 defects, right? Either 3 people or 4 people, not 3.5 people. Whereas attribute data, we said it is categorical and it is used to describe the characteristic or qualities and can be classified into categories, right? Okay. So we have said that the shoe size is small, medium, large, customer satisfaction level, satisfied, neutral, dissatisfied, or the color of shoes. These are all categories. Okay. So its characteristic is the values are represent categories or labels rather than numerical values. We have seen that enough. Okay. After explaining enough, I'm just going into a little bit of deeper understanding of this. Okay. Can be nominal also, like no inherent order, like the color of shoes. Okay, black shoes, brown shoes, white shoes, etc. Okay, and data is not numerical, rather descriptive. This is a very important word. Attribute data is categorical, it's not numerical, it's rather descriptive. Okay, in summary, discrete deal with countable quantities. Attribute deals with categorical characteristic. If this is crystal clear, type CC in the chat box. Crystal clear in the chat box. We'll go on to question answers. How many of you are ready for the Q&A? Type ready in the chat box. Let me go for a couple of questions before we go into the depth of each of these data. Fantastic. Okay. Good. I will share with you all the presentations. If anybody is interested in an internationally recognized certification, just join the upcoming webinar in the link that I posted in the chat box, and I'll see you in this. The question is, what is an example of continuous data? Okay. Number of defects, temperature in degrees, category of items, pass or fail. Which is an example of continuous? All right, it's a simple one, right? After talking so much, it becomes very simple. The correct answer is temperature in degrees. Thank you very much for your participation. Okay. Let's go to the next question. Which of the following is an example of discrete data? Which is the example of a discrete data? Let's check. Height in meters, weight in kilograms, number of students in the class, and time in minutes. Let's see this from everyone, which is an example of a discrete data. Simple. Okay. So all of you got the correct answer. It's number of students in the class. All right. Now let's see the levels of data. Okay. All of you type LOD in the chat box. Let's see the level of data. Different levels. The same thing, whatever that we are going to talk in the attribute, we are going to explain in depth in the levels of data. Okay. Now, 4 levels of measurements in data: nominal data, ordinal data, interval data, ratio data. Okay. How many of you find it interesting? Type interesting in the chat box. Let's see how many of you type find it interesting. Good. Superb. Thank you very much for your active participation. I'll just quickly tell you, though there are 4 levels of data here, 4 levels of measurement: nominal, ordinal, interval, and ratio, categorizes and label variables, ranks categories in order, has known equal intervals, has true or meaningful 0. And if you see here, ratio data has all the 3, interval data has 3 of them, ordinal data has ranks category, whereas nominal data, it is just. The more is the information you have, these levels that you have, the more rich in information it is. If you can see this, type I see as I can see in the chat box. You have all this information here, then it gives the richness. That's how you call the data as very rich. Nominal data you have already seen. It's a lowest level of classification. It's a lowest level of classification. Numbers acts as a label for this qualitative data characteristic. For example, birth states in a class, Texas 1, Louisiana 2, etc. Okay, labels don't represent quantity, only category. The central tendency is mode. Please write that. Generally in the central tendency, mean median mode we have spoken about earlier. Mean median mode, if you remember. Okay, central tendency is mode, which is a frequently occurring category. For example, how many of you like blue? If many of you typed blue, then blue is the mode for that thing. So the central tendency is the mode. Example, mode is equal to 3, which means that Arkansas with 10 students is the maximum. Okay, we can't do much statistical analysis, but some analysis is possible using a software. So this is the nominal data overview. Okay, so let's ask some questions on the nominal data. How many of you are ready? Just type ready in the chat box if we can go for some questions on nominal data. All right, let's go for some questions on the nominal data. So each of the data I'm explaining and immediately asking you a question, because you don't forget it, you reinforce in your memory, okay? So which of the data types use labels to categorize qualitative data without a meaningful order? If it is in order, then it is ordinal data, okay? But without any meaningful order means it is, which is the right answer? Of course, A, right? That's what we are talking about. Fantastic. Okay. Now, let's go into ordinal data. We've already seen ordinal data. Nominal data, we've seen, okay, how many of you like pens, pencils, papers, cow, cat, etc. Ordinal data is like in the order, okay? Excellent, good, bad, fantastic, and all that. And it is little better than the nominal data. Under the attribute data category, it is little better than the nominal data. Example in FMEA scales, okay? FMEA is one methodology which we spoke in the last session, the failure modes and effects analysis, and ratings, pain levels, okay? So you can use either mode or median as central tendencies in this data, okay? And key feature is order matters, okay? Order matters. That is what is important in this, okay? So rated movies as 2, 5, 6, 9, 9 being her favorite, etc. Okay, we've already seen this enough. Okay, the limitation is intervals between the numbers don't indicate the exact differences in preference. Okay, so that's the limitation of this ordinal data. Okay, if this ordinal data is clear, type super clear in the chat box. Now we have a quick question and answer on this ordinal data. Okay. Okay, let me ask the question answers. Now the question is this, okay? What distinguishes between ordinal data and nominal data? Okay, now A, it has categories. B, it provides an absolute 0. C, it provides a meaningful order or ranking. And D, it measures the continuous variables. Okay, what is the correct? Oh, I jumped into the correct answer. Okay, what's the correct answer? All right, it provides a meaningful order or ranking. Okay, great. Superb. Okay, interval data. This is a little bit interesting. Higher data classification. First, we see nominal data, which is the lowest continuum. Then we went to ordinal data. Now we are going to interval data. Interval data is highest data classification. Numerical values with meaningful intervals. The key features is differences between values provide some insights. Differences between values provide some insights. For example, temperature at 8 a.m. is 76 degrees and temperature at 9 a.m. is 80 degrees. Okay. Okay. So continuous or quantitative allows for advanced statistical analysis. And the difference from ordinal is the interval shows the exact differences, not the ranks. Okay. So I've just given this example here, and you can see that how the interval data is analyzed. The temperature is like this, the trend goes like this. Okay, there are some parametric statistical tests for this, but then the income ranges, you see, 19 to 29K is so much, 30 to 39K is so much, 49 to 14K is so much, and IQ score, it's in the intervals. If interval data is clear, type, give me a 9 or 10 if it is super clear. I'm sure this example is clear. Temperature at 8 a.m. and temperature at 10 a.m., etc. Okay, good. All right, let's go to the last part of this data, which is, so which type of data allows for the calculation between the differences between the values but lacks absolute zero? Okay, put it in the chat box. Of course, see the correct data is the interval data. Okay, I will also ask one more question. So in which type of data are the intervals between the values meaningful? There are no true 0 points. Again, the answer is interval data. Okay, I'm not asking you because we are running short of time now. And the last one, which is the characteristic, which characteristic is specific to ratio data but not to interval data? Okay, this I will open up the chat box for your answer. It has an absolute 0 point. It uses numbers to rank items. Okay, so all of you had the correct answer. It has got an absolute 0 point. Okay, the last data point is something called as a ratio data, which has got highest data classification. It can be continuous, discrete, force, voltage, heights, defects per million unit, all that, the continuous variables that we have got. This data is analyzed by mean, median, mode as a descriptive statistics. Okay, we have a lot of parametric tests also on this, but these are all simple. You know, it's a continuous data. Okay, it can be continuous or discrete data. This is the ratio data. Which of the following types of data is considered to be highest level of data and classification? The answer is the ratio data. Okay. So which of the following data types has the highest level of data classification? Please put it in the chat box. Yeah, that's a ratio data. Okay. And here, which data type could be either discrete or continuous? Again, the answer is yes, it's a ratio data. Okay. Okay, I want to summarize this by two things. One is you can have the input as the discrete data or the input as continuous data. You can have the output as discrete data or the output as continuous data. Okay, so in Six Sigma we call it y is equal to f of x. It can be input can be discrete, output discrete. The input can be discrete and output can be continuous. The input can be continuous, the output could be discrete. The input could be continuous and output could be continuous. Okay, so this is something that we'll go deeper when we do the test, different parametric test. Okay, the last question I guess for today is the central tendencies that is most commonly used for nominal data is what? Okay, let's see whether you remember nominal data now. Yes, that's a mode.